recording with audio. Okay, I think it's working now. X to the third. Oh, 0.001 x to the third. Okay, so there is something different. I'm sorry, I didn't read the whole thing, but it says also. Okay, let's read it. A manufacturer determines that the cost of making X units of a commodity is this. And the demand function is P of X equals 48.2 minus 0.03x. Graph the cost and revenue functions and use the graphs to estimate. So that's not what we wanted. Use calculus to find the production level for maximum profit. Okay, estimated. Okay, so I thought it was maximizing or minimizing. I mean, minimizing the costs. So you still want to go ahead with this, or you want me to continue looking for a cost?
I found another one, I think.
Oh yes, awesome. I'm ready.
Okay, it says a rectangular storage container without a lid is to have a volume of 10 meters cubed. The length of its base is twice the width. Material for the base costs $15 per square meter. Material for the side costs $9 per square meter. Find the cost of materials for the least expensive quantity.
Okay. I thought we did this one, but maybe not this one. Maybe something similar. Okay, so this is the volume, and this is x, and this is twice x. And for the base was $15 per square meter, and for all sides the same, $9 per square meter, correct?
Yes.
Okay, perfect. Good. So we want to minimize cost. Excellent. Perfect problem. That's what I thought that one was going to be. Okay, so first of all, the volume of a box is area of the base multiplied by the height, which I did not denote yet. I didn't label. So this must be x times 2x and times h. So 10 equals 2x squared h. And from here, h will be 10 divided by 2x squared, or 5 divided by x squared. At this point, I need to find the cost of the entire box.
I have a question.
Please.
How'd you get the area of the base? X times 2x.
Oh, I thought you said that the length is twice the width.
Oh, okay.
Sorry. Maybe we should read it.
You're right.
No. Maybe did I understand that correctly?
No, you did. I just didn't pick up on it.
Okay. Sorry about that. So the width, they say that the length of the box, because it's not a square, so it's a rectangular base. So the length of the box is twice the width. That's why I wrote here x and here 2x, and then the height is unknown. Is that better, everyone? So now the cost of the base is the area times the cost per square meter. So this will be 2x squared times 15 plus. These sides cost the same, but they don't have the same area. So this one, for example, there are two of those multiplied by base times height, x times height, times the cost of 9. But then plus two of those that have a base of 2x and height of h. So 2x, 2 times 2x times the height, which is 5 over x squared, and also times 9. See if this is okay so far before I try to simplify, because I have to simplify as much as possible. Basically, from this moment on, smooth sailing. I determine the derivative, find critical numbers, and set equal to 0. But is this okay so far? Do we understand how was the cost determined? Okay, I'm assuming that you said yes. So this is 30 x squared. So here I simplify, and I get 10 times 9, which is 90 divided by x. And here I have 90 but times 2. So this is plus 180 divided by x after I simplify an x. So finally, I have 30x squared plus 270 over x. And from here, I will not find the least common denominator. I don't need it for this function because it's easier to differentiate as is. And this is 60x minus 270 over x squared. This one, I need the least common denominator. So I need to multiply the top. So this is 60x cubed minus 270. This function cannot be undefined because x cannot be 0, but it can be 0, which means the numerator is 0. 60x cubed minus 270 equals 0, or x cubed equals 27 over 6. And when I take the cube root, I get that x equals 3 over the cube root of 6, whatever that is. And I will approximate it, of course. But now I need to show C prime, whatever that number is. And this is 0. And I study the sign of this expression, not in the denominator. I refuse. It's positive always. So in the numerator, I can plug in 0, and this is negative. And if I plug in 100, this would be positive. So this is obviously a minimum by the sign of the derivative. If I'm asked to find the minimum, then I will have to find C of 3 over the cube root of 6. And then plug it in here. So it will be 30 times 3 over the cube root of 6 squared plus 270 over the cube root of 27 over 3 over 6. So let me approximate these. What am I doing first? I'm doing this. So 3 divided by 6 to the power 1 divided by 3. I got 1.65. 1.65. And here I want 30 times the previous answer squared, and then plus 270 divided by the previous answer. And I get 245.311. So $245.31. And that will be the minimum cost. Very good problem. Thank you for finding it. Good. Next question. Anything else? Other problems? Anything, any type? Is there anything else you would like to review? Maybe L'Hopital's rule? Anything else?
Can we do another Newton's method?
Yes? Is there a particular problem? I mean, a particular issue, I should say, with Newton's method?
I had a question.
Yes,
Hold on.
any question. But is there a particular issue with it, or something we don't get, or we need help with, or you know what I mean?
Oh, no, not really. I just want to practice it.
Okay.
One I found was sin x equals x minus 1.
X minus 1?
Yes.
Okay, perfect. So our first step has to be this. Our second step has to be this. Let's also find the first derivative right away. So this is cosine x minus 1. And we have to say, number one, that the function is continuous and is differentiable. I really don't need the differentiable part. I only need the continuous, but I need to find the interval. And show that it changes sign. So make sure you have the mode in radian mode. Go to y equals and put in the function sine x and minus x and plus 1. And we go to second and table. And I'll plug in 0 and 1 and then 2. And I found an interval between 1 and 2. So 1 and 2. Because at f of 1, the function is positive, and at f of 2, the function is negative. And it doesn't matter where I start because the derivative is not 0 at 1 and it's not 0 at 2. These are radians. Cosine 1 radian minus 1 will not be 0. Cosine 2 radians minus 1 will not be 0. So let's say we start where you want to start. And then from here, from all these, except that I don't need the differentiability, by intermediate value theorem, there exists C in the open interval 1, 2, such that f of C is 0. And I'm looking for that. So then x1 and then x2. So here's the Newton's function that we want to plug in, sine x minus x plus 1 divided by the derivative, which is cosine x minus 1. So do not erase. Go to y equals, insert x minus, parentheses around everything you had before, and divide by cosine x minus 1 and close the parenthesis. Where would you like to start? It doesn't matter. One, that's fine. So get out of there with second and quit. Go to variables, go to y, the function, and plug in 1 first. That's our first response. 2.830487722. And you can say, oops, wait a minute. I expect the solution to be between 1 and 2. Why was all this 2 point? It's possible to start like that. It's okay. As long as quickly it will converge to a number between 1 and 2. The first one, even the second one, could be off, but that's okay. So now all we have to do is copy, but replace 1 by the previous answer. Okay? So it will converge. Oops, that's not good. 2.04955.245. I don't know why I squeezed my function here on this side. And then x sub 3, the third iteration, 1.938656127. It didn't tell me how many digits are we looking for. 1.934568962. And if we want 5 digits, we already got that. If we want more than 5 digits, we have to continue. It's probably the last one. We'll see. Yeah, everything is the same. So the method converges in 5 iterations. Most probably if we start, because it's so close to 2, if we start at 2, it will probably converge in 4 or less. This is not unusual. You should just have to think and say, oops, wait a second, what's going on here? But if you see that it converges, then you are on the safe side.